Picture a world wrapped entirely in absolute darkness, hundreds of millions of miles from the warmth of the sun. This is a 4.5 billion-year-old sphere suspended in the deep freeze of space. At first glance, Jupiter's sixth satellite, Europa, looks like a giant floating snowball. It is wrapped from pole to pole in an impenetrable armor of solid ice. Those barren, lifeless features are hiding a massive, pitch-black saltwater ocean right beneath the crust. This underground water holds the chemical stability and liquid environment required for extraterrestrial life to persist. The immediate problem we face is access. We are trying to look inside a world that is locked away beneath a shell estimated to be 10 to 20 miles thick. Figuring out what is swimming around down there in the dark means we have to leave our Earth-centric assumptions behind and rethink exactly how biology survives in extreme conditions. This diagram illustrates a vertical cross-section of Europa. The icy crust sits above an underground ocean that drops a staggering 40 to 100 miles deep. And this colossal body of water is highly active, constantly churning under the surface. The pressure building up inside is so intense that plumes of liquid water actually erupt through massive cracks in the ice, shooting straight out into the vacuum of space. Looking closely at the surface where those cracks form, we see a vast network of strange red streaks and yellow spots scarring the ice. Those red streaks are a frozen mixture of water and salts, and the yellow spots contain sodium chloride, the exact same table salt you put on your food. When you compress that table salt and water together at freezing temperatures under extreme high pressure, they form a completely new type of solid crystal that exists deep down on the ocean floor and right up on the surface. Europa contains the specific chemical ingredients, liquid water, and necessary thermal energy to support biology. Finding a way through 20 miles of solid ice seemed nearly impossible until a planetary scientist looking closely at photos of Europa spotted strange two-peaked structures called double ridges. This diagram shows a cross-section of Earth's high-pressure ice sheets. We have the exact same double ridges here, where liquid water pockets freeze and thaw. Under extreme pressure, the expanding ice forcefully pushes the top layer upward, cracking it into a distinct two-peaked ridge. Finding this exact same geological process on Europa tells us that shallow pools of liquid water exist less than 1 mile beneath the moon's surface. We do not need a massive drill to bore deep down into the dark. The most accessible alien habitats in our solar system could be waiting just inches under the top layer of ice. That proximity to the surface sounds dangerous when you consider the host planet. Jupiter constantly blasts its surrounding moons with intense, lethal radiation. Europa's massive ice shell functions as a natural radiation shield. The dense upper layer of ice absorbs all that lethal cosmic energy. This transforms the shallow, subsurface water pockets into stable, shielded environments where microbes can safely thrive. We are about to check those pockets. NASA's Europa Clipper and the European Space Agency's JUICE missions are already built and navigating their way through the solar system. These highly advanced exploratory probes will arrive at Europa around 2030 to finally scan the ice and search for biological signatures. Decades of science fiction have conditioned us to look for flying saucers or massive alien cities when we gaze out into space. But the discovery that finally answers the question of whether we are alone in the universe will likely be tiny microbes swimming quietly in a pitch-black saltwater pool millions of miles away in the dark.